Hello everyone and welcome back to Arctic Retro. It's time for another computer build. As you know, I like to restore old computers. I also like to repair them if I can, but most of all I like to build things. And that's what I'm gonna do in this series that starts with this episode. So what am I gonna build? Well, I'm gonna build a Commodore 64C using this fantastic motherboard that was designed by Bwack. Bwack is a YouTuber and he's an electronics hobbyist, and he makes lots of stuff for the C64 and other stuff before. He actually made a KU motherboard replica a couple of years ago, which I built before, and that was a great fun project. He has also made the C64 saver and the Versa cart for the Commodore 64. You should check his channel on YouTube on Bwack, and also his GitHub page, which I'll link down in the description. My favorite computer is the Commodore 64, and here is one. This is a Commodore 64C, and this is what we're gonna build using the motherboard, because this is a 250-469 revision 4 Commodore 64C motherboard, and this is a replica made by Bwack now just recently in 2023. He's been working hard on this for a while, and yeah, he got 2 of these boards produced, the prototypes boards, and they were made by PCBWay. Before I continue, I just want to thank my sponsor PCBWay. They provided the PCB for this Commodore 64 build, and it's a very good quality PCB, as you will see through this video. So what do you need to do if you want to have produced this PCB yourself? Well, you simply just visit PCBWay.com, you enter the necessary data, you select the number of PCBs you want and what kind of type you want, and then you can upload the Gerber files. Once these are published on the GitHub site of Bwack, you can actually download it and upload it here and get an instant quote. And in here you select the various parameters for your choosing, the colors of the solder mask, what kind of surface finish you want. If you want to have gold, then of course that costs a little bit more than not gold. In fact, for smaller PCBs you can get as much as 10 pieces for just $5 and the build time is just 24 hours. Besides PCB prototype production, they also do CNC machining, sheet metal fabrication, and also know 3D printing. So they got you covered for all your needs for your hobby projects. Also check out their shared project site, where you can find a lot of cool projects that's already made, and you can just place them directly into the shopping basket and have PCBWay produce them in no time. So head over to PCBWay.com now and check out their services. So doesn't it look fantastic? I mean, I have never seen a Commodore motherboard, or actually any PCB quite as this, and it's made with gold plating, and it has a semi-transparent solder mask, as you can see, and it's just as beautiful on the back side. Building a machine like this from parts is quite a big task, and it takes quite some time, so I'm not gonna finish this in just one video. I'll probably make like 2 or 3 videos. We'll see about that and see how it goes. I'm not really sure. Anyway, in this video I'm gonna start the planning and also start soldering up some components. I am gonna use this real working Commodore 64C as the host machine for parts I need. I'm gonna use the case, I'm gonna use the keyboard. However, I'm gonna do something special to it as well. I don't know if you have noticed, but I actually have a Commodore 64C motherboard up there on my wall. This is a parts board. It is missing a few things, but I'm gonna utilize that as well. I'm not gonna completely butcher this machine here, and yeah, after I'm finished building the new machine, I'm gonna repair the one that I broke to get parts from, and that will also be a machine in the future that's usable. To build up a motherboard like this, there's several hundred components and a lot of soldering, a lot of chips, and I have ordered all the parts that I need that can be ordered as new from DigiKey. And yeah, these are the capacitors, resistors, diodes, certain chips, sockets, inductors, yeah, everything you can find on DigiKey and Moser as new I have gotten here. And that was actually my contribution to Bwack and his project. That was to find the parts on DigiKey and note down all the parts number, and yeah, so we have that in a sheet alongside with the Moser part numbers. DigiKey and Moser are well-known, good quality suppliers of electronics, so yeah, best to use some good sources and not rely on cheap parts from China, for example. Alright, that's enough with the talking. Let's actually get to work here and start populating this PCB. Before I start soldering, I'm gonna clean it up with this cotton pad and some isopropyl alcohol so that we don't have any fat stains from my fatty fingers, and yeah, there might be some leftover residues from the production at PCBWay, but it looks very clean and very nice. So it's almost like I want to frame this and hang it on the wall instead of building it, because it's such a nice board. The thing is, this is a replica. It has been designed from the ground up by reverse engineering a real Commodore 64C motherboard by Bwack, and this is the first prototype, 102. Bwack has the other one, but no one knows if these are actually working, if they have any faults or not. So that's part of this mission, is to actually figure out if this board works, and if it doesn't, then what is wrong and how to fix it. I'm gonna start by organizing all the parts, and I'm gonna print out the BOM or bill of materials so that I have something to follow and to cross off of each component that I solder in. So it's important to be organized. You can't just start soldering on random. You need some system and order, or else you will probably do a mistake or forget some parts. I'm not sponsored by DigiKey, but I really like them. They have excellent service. They have most of the things you need in stock, and they have a very fast shipping, 4 or 5 days from the USA, and free shipping if you order for like $40 or $50, I don't remember. Okay, here's a lot of components, and you can even buy 1 or 2 of components. They don't cost more than a cent each, but still you can buy. You don't have to buy large boxes or sets like this. This is 2 diodes. This probably costs no more than 50 cents, I guess. But all in all, this box, I ordered the parts. It came on around 70 euros. or dollars. And that's just the parts that can be ordered from DigiKey as new. I also need some other parts like contacts and chips and things like that. That I'm gonna find later, but I am calculating that this total build will cost me around $200 or euros. And that's without the cost for the PCB. The actual motherboard we got for free from PCBWay. But if you're gonna order one or two of those yourself, it's gonna cost you like, I'm not really sure, 50 to 100 euros, because that's some large PCBs. That's really a large heap of components. By the way, Bwack is also gonna build this board, and he will probably release his own videos. So I recommend you see his videos, and yeah, there you can get the history behind this motherboard. Okay, I'm gonna find all the lowest profile components first, like the sockets, resistors and the small capacitors and things like that. It's always a good idea to start with the smallest components first. Let's take a look at the actual bill of materials. Yeah, and here's the Google Sheet for that, and yeah. We have all the labels for the components and their values and the footprint and the Moser part number and DigiKey part number. So yeah, I can see here that there's one mistake here. I think I am not gonna use the choke filter that I ordered. Bwack has corrected this, and we didn't find any new replacements for that, so I might probably use the one from the old machine. There's also an interactive bill of materials that Bwack made, and this will be published on his GitHub page later when he's ready to publish this project. And this is very handy because you just click on the components and you get the marking on the actual PCB where those components are. So that's very nice. And you can also do it reversely. You can click on a component and then you will find it in the bill of materials. Okay, it's time to start working. I have printed the bill of materials, found the smallest components, and yeah, let's start a little bit of soldering. I'm gonna be pretty detailed in these videos. I'm not gonna show you the whole process of soldering every component, but yeah. I know that many of you like to see soldering and like to see detailed videos, but I'll try to not make it too boring. It's such a nice board. It's almost like I don't want to touch it because I leave my fatty fingerprints, but I guess I'll have to do it, and I'm gonna clean it very well after building it, obviously. Okay, I'm gonna follow the list, and the first components is 0.1 microfarad ceramic capacitors. There's 17 of those. I chose blue capacitors wherever I could because I think that looks nice and it will look nice on this PCB. There are other variants like yellow color, but yeah, blue is nice. Of course, there is silk screen writing on the board that tells you where all the components go. However, since this is a prototype, I need to just make sure that everything is correct, and yeah, I'm gonna double check with the interactive bomb. These small ceramic capacitors are not polarized, so it doesn't matter which way you place them. However, I like to place them in the same direction if I can. This has writing on one side, so I'm gonna place the writing the same direction on all of them. Yeah, and the first one goes here. Just try and bend the legs. I want to make this as nice looking as possible. That means I want to have components straight and things like that. I don't want to do too many components at the same time, so I'm starting with these 5 here. Just solder them in. This is a brand new high quality PCB with gold pads, and there's no need to use any flux, so I'm not gonna do that. I have a very thin lead based solder actually, which is perfect. I set the temperature to 360 degrees Celsius. Okay, let's start soldering. So I'm not really sure how long time this is gonna take, and yeah, we'll see about that. It's Saturday today. Alright, here goes the first component. Yeah, that worked very nicely. Very easy to solder on this PCB. Yeah, that went well. Ideally, when you're soldering components, you should try to get solder to flow through the hole and come out on the other side, as you can see on this one. Just one of the pins got through and the other one is not filled completely. That can be a bit tricky to get right, but you could try and fill it from the other side, or you can just leave it. It's not that a big deal, I think. Big planes of copper like this requires more heat, so from time to time I just need to raise the temperature on the soldering iron, because if you have too low heat and the big copper plane draws away all the heat, then the solder won't flow efficiently and you end up with a bad solder joint. Alright, that was the first 17 components. I got 3 left because I always order a couple of extras in case some part is damaged or gets lost. Next up is some more capacitors. I'm just gonna solder in all those caps and then I'll be back. That was all the small ceramic caps. Don't they look nice on this board? Looks like we're building a little city, and these are all the streets and infrastructure, and now buildings are popping up. Next I'm gonna do the small diodes and the resistors, ferrite beads. Actually there isn't a lot of resistors. However, these kinds of components needs to have their legs bent, and I usually just use a plier like this. Try to find the correct width, but yeah, you should never bend it right next to the actual component, because then you might break off parts of it, but a little bit outside like that. However, looking more closely at the PCB, I can see that this is a very narrow resistor placement, so we need to have it standing up. So that will be like this. Then a little bit more soldering. I changed to a bigger tip, but I think this solder tip is pretty poor, so I'm gonna change back to my tin one. Now here is R1, and this one is laying flat, and this is a big resistor. It should be half a watt capable. Maybe I should have found a bigger resistor, but this is half a watt, so that's good enough. Alright, I'm gonna populate the rest of the smaller component that looks like resistors, the diodes and the ferrite beads, and then I'll be back. Alright, some more components are finished, and I decided to solder in the sockets now. Actually, thinking about it, I should have started with the sockets because they are some of the lowest profile components, but I didn't, so I'm just gonna do it now before I place any higher components. It's not a big deal, but it's easier to solder them in if they can lay flat on the table. Just need to find the correct direction, and the notch is pointing upwards. I usually just solder in 2 of the corner pins first, and then I adjust it with my finger on the other side so that it's sitting flush with the board. Yeah. Then must not forget to solder the rest of the pins. All the sockets except the one is now soldered in. The last one is this one. It's for that big PLA chip. That's a combination of several chips in one, and it has a different pitch. That means it's more narrow between the pins. So I was a little bit unsure what kind of socket, and it was kind of hard to find the socket for it, but I got this one. I think this one is the correct, and yes, it fits. So let's solder that in. With a small pitch like this, it's easy to bridge together a couple of pins if you're not careful when soldering. So that's why I'm gonna test now to see that none of the pins got bridged. Just gonna test it from the socket. I'm just testing all the neighboring pins to check if they are connected, which they shouldn't. And no bridge detected. Nice. That was all the sockets in place, and now this board starts looking like a computer, I guess. Okay, I'm gonna solder in some more components, and then I'll be back if something special arises. Soldering in the bridge rectifier, I noticed that it is actually too large for this board. So this is not the correct part, but electrically it is okay, but the dimension is too big, but I think I can fit it in there anyway. Just push it down there. It doesn't need to be all the way down to the board, but yeah, like that. Alright, I have gotten most of the smaller parts in, and this is starting to look really nice. Everything has went well so far. A couple of things I'm not happy with is, for example, these rows here are a little crooked. These diodes over here are also placed a little bit crooked in the holes. I'm not gonna fix that, I think. Also, a couple of the capacitors that I ordered should have been a little bit different size, but they are the correct value, so actually no issue there. However, there's a couple of things that might be an issue here. I got this choke coil here, and yeah, it's actually kind of hard to find the correct one that's supposed to go there. There's actually 8 holes. I'm not really sure. This doesn't have the correct pin width for one. However, this is the same choke that I got for the previous Commodore 64 that I built, and that was the correct one for that machine. Another thing we have is the crystal oscillator. I couldn't find that big oscillator that's supposed to be on this board originally. I only got this smaller variant, and yeah, they fit the holes, but I'm not really sure if that is the correct one. It has the same frequency, so yeah, it might be working. I'll test it out. If not, I'm gonna steal one from the other machine. So I just place it like that. Not really sure if it should be connected to ground like this. We'll see about that. I might talk a little bit with the expert Bwack, what he says. A little blob of solder there. Then we have the header for the keyboard connector, and here you have to remove one of the pins. Just pull it straight out. Now it's completely flush. Alright, all the smaller components are in except for that choke filter, and now it's time to solder in the connectors. I got a couple of brand new ones, 9-pin D-sub connectors here for the joystick ports. I think this fits perfectly. Besides that, I'm gonna harvest some components from this parts board here. I have a few things here that I need, and among other things, this big PLA chip here, and the cartridge connector also necessary. And here's that filter. I'm gonna use this, I think. But that you have to wait until the next episode. That was it for this episode. This takes a while to complete, so I actually need a little bit of time to finish this up. Therefore, I'm splitting it into more than one video. Hope that's all right. Okay, hope this was interesting. I'm really looking forward to starting to power this board up and see if it actually works. That will be great fun. Thanks for watching, and a special thanks to my patrons. See you, bye bye.